Stan Gibilisco here with an explanation for the answer to final exam, question number 72, found on page 676 of Teach Yourself Electricity and Electronics, 5th edition. The question says this: when we want a transistor to act as an RF power amplifier in a wireless transmitter, we might choose a common base circuit over a common emitter circuit if we want to avoid what? And the choices go excessive drive, insufficient power output, parasitic oscillation, insufficient sensitivity, or all of these. Let's go back to chapter 22 and look at figure 22-10. That is the generic circuit for a grounded or common base bipolar transistor amplifier circuit. Notice that the input goes to the emitter rather than the base. The result of that configuration is that we have a low input impedance for this type of amplifier, and the amplifier tends to draw some power from the drive or the source that we apply to the input, the drive or power source that we apply to the input of this circuit. The result of that is that we're less likely to get feedback induced oscillation in a grounded base amplifier than we are in a grounded emitter amplifier where we would apply the input to the base circuit. So, the correct answer to this question is C, as in Charlie, parasitic oscillation. If you will remember, parasitic oscillation is a situation where an amplifier, particularly a radio frequency power amplifier, acts as an oscillator, generating signals at frequencies other than the one that we want. The term parasitic arises from the fact that these oscillations tend to rob power from the legitimate signal and deposit that power in the form of signals on unauthorized and unwanted frequencies. Parasitic oscillation is a bad thing. Sometimes that situation is called spurious signals or spurs. Again, the correct answer to this question is C, as in Charlie. Stan Gibilisco signing off. Oh, by the way, I would recommend that book if you want to get away from the mundane humdrum reliance upon the electric utilities, but that's a topic for an entirely different video. Stan Gibilisco out.